we have learned how to define trigonometric ratios using a right-angled triangle. Did you notice that we have defined the trigonometric ratios for acute angles only? This is because the angles in a right-angled triangle, apart from the right angle, are both acute angles. Does this mean that trigonometric ratios are defined only for acute angles? Or can we define them for other angles too? The trigonometric ratios are defined for the other angles as well using the unit circle. The measurement of a complete circle is 360 degrees, so we can get the value of trigonometric ratios for the other angles too. Let's learn about this in detail. Let's consider a unit circle whose center lies at the origin called O. Let's take a point P on the unit circle. Let the coordinates of the point P be A, B. Segment OP is the radius of the circle, which is 1 unit. Draw a perpendicular from point P to the x-axis. We can see a right-angled triangle OPQ formed here. Let's say the angle POQ is theta, the length OQ equals A units, and the length PQ equals B units. In the right triangle OPQ, using our previous knowledge, we know that the trigonometric ratio sine theta is defined as the ratio opposite side over hypotenuse, which is equal to PQ over OP. Since OP, the radius of the circle, is equal to 1 unit, we get sine theta equals PQ, that is B. In other words, the y-coordinate of point P represents the value of sine theta. Similarly, we know that cos theta is defined as adjacent side over hypotenuse, which implies that cos theta equals OQ, which in this case equals A. That is, the value of the x-coordinate represents the value of cosine theta. As you can see, the coordinates of point P change according to the change in value of the angle theta. As a result, the values of sine and cosine change according to the change in value of theta. For the angle 0 degrees, the value of sine theta equals 0 and the value of cosine theta equals 1. Next, for the angle 30 degrees, the value of sine theta becomes 1 over 2 and the value of cosine theta becomes the square root of 3 over 2. Next, for the angle 45 degrees, the value of sine theta becomes 1 over the square root of 2 and the value of cosine theta also becomes 1 over the square root of 2. Next, for the angle 60 degrees, the value of sine theta becomes the square root of 3 over 2 and the value of cosine theta becomes 1 over 2. Next, for the angle 90 degrees, the value of sine theta becomes 1 and the value of cosine theta becomes 0. What happens if the angle is more than 90 degrees? The value of the cosine becomes negative here. Next, for the angle 135 degrees, the value of sine theta becomes 1 over the square root of 2 and the value of cosine theta becomes minus 1 over the square root of 2. And for the angle 180 degrees, the value of sine theta becomes 0 and the value of cosine theta becomes negative 1. Similarly, observe that when the angle is 240 degrees, the value of sine theta becomes minus 1 over 2 and the value of cosine theta becomes minus the square root of 3 over 2. Similarly, observe that when the angle is 270 degrees, the value of sine theta becomes minus 1 and the value of cosine theta becomes 0. And when the angle becomes 360 degrees, the value of sine theta becomes 0 and the value of cosine theta becomes 1. Is it possible to extend sine and cosine for angles greater than 360 degrees? Yes. As you can see, for the angle 450 degrees, the value of sine theta becomes 1 and the value of cosine theta becomes 0. And for the angle 540 degrees, the value of sine theta becomes 0 and the cosine value becomes -1. We can observe values for all the angles. Now what about negative angles? Are the trigonometric functions sine and cosine defined for negative angles? Yes, they are defined for negative angles too. Recall that an angle measured in a clockwise direction is called a negative angle. For the angle -90 degrees, the value of sine theta becomes -1 and the value of cosine theta becomes 0. For the angle -180 degrees, the value of sine theta becomes 0 and the value of cos theta becomes -1. Similarly, for the angle -270 degrees, the value of sine theta becomes 1 and the value of cos theta becomes 0. And for the angle -360 degrees, the value of sine theta becomes 0 and the value of cosine theta becomes 1. Notice that the value of the sine becomes 0 at the integral multiples of 180 degrees, while the value of the cosine becomes 0 for all the odd multiples of 90 degrees, that is, for the angles of the form 2n plus 1 times 90 degrees, where n is an integer. So we can conclude that the trigonometric functions sine and cosine are defined for all real numbers. Notice that the values of sine and cosine functions are not unique. The values of sine function are the same for certain angles, and the values of cosine function are the same for certain angles. In fact, they repeat after a regular interval. This is called the periodicity of the function. Let's find out the periodicity for sine and cosine functions. As you can see from the table, the values of sine and cosine functions repeat after an interval of 360 degrees. This can be observed from the unit circle as well. Therefore, the periodicity of sine and cosine functions is 360 degrees. The values of other trigonometric functions, such as tangent, can be obtained using the values of sine and cosine functions. We know that the trigonometric function tangent is defined as the ratio sine x over cos x. And the value of tan becomes 0 when the value of sine is 0. Notice that the tangent function is not defined when the value of the cosine becomes 0. Since the value of the cosine function becomes 0 for all the angles that are odd multiples of 90 degrees, that is, cos x becomes 0 for x equals 2n plus 1 times 90 degrees, where n is an integer, and the tangent function is not defined for the angles of the form 2n plus 1 times 90 degrees, where n is an integer. As you can see, the value of tan 30 degrees, that is 1 over the square root of 3, is obtained by taking the ratio of the values of sine 30 and cos 30. Next, the value of tan 45 degrees, that is equal to 1, is obtained by taking the ratio of the values of sine 45 and cos 45. Similarly, the values of tan 60 degrees, that is equal to the square root of 3 is obtained by taking the ratio of the values of sine 60 and cos 60. We have derived the fundamental trigonometric identity in our earlier classes using a right-angled triangle, that is, for acute angles only. Let's now verify whether this fundamental trigonometric identity holds true for the other angles as well. The value of sine squared x plus cos squared x is always equal to 1 for all the values of x where x belongs to the set of real numbers.